Well, good afternoon, ladies and gentlemen. My name's Cliff Marshall, and the company is Esslab. We're introducing today an entirely new and innovative product, which is a standards preparation system. This is a collaboration that Esslab have had with Sartorius and Hamilton. Sartorius being one of the world's leading manufacturers of high-precision balances, and Hamilton being probably one of the world's leaders in high-precision liquid handling. What we're looking at today is a technique which will change the way in which laboratories actually carry out their work in analytical analysis. Where we have at the exhibition today, many companies who are presenting instruments which show precision and readability which go down to the parts per billion level and sometimes lower, using techniques like mass spectrometry to give values assigned to the analytical methods that I have. Unfortunately, the methods at which we are still using today, the preparation of standards, quite frankly, haven't changed since the alchemists several hundred years ago. We're using glassware, which actually is a by sight, by eye measurement of volume, using lines on glassware, using solutions and solvents, which we've not controlling temperature. And quite clearly, what we don't have there is any level of traceability on the preparation of the standard that's being used in the labs. And this is a method by which analytical laboratories are able to show both accuracy and precision. It's very easy for their ISO 17025 techniques to show that they're showing precision, but they may be precisely inaccurate. So we're moving away from, as we've said, the time-consuming methods of preparing standards using laboratory glassware by incorporating products from the manufacturers are stated, error-free, to a level that we've not been able to realize before now. So we've utilized these pieces of instrumentation, which is a Hamilton, if we can actually change over the screen. Okay, what we can see here is a Hamilton dispenser diluter. This is a Microlab 600 instrument. These instruments incorporate a high-precision drive, which over its length has 48,000 steps. This means that we can provide dispensing volumes to levels of precision that wouldn't be realized by standard pipetting techniques in this positive displacement, totally inert fluid line. The unit is actually linked in conjunction with the Sartorius Cubis range of balances. These instruments also have a high level of precision, and in this instance we are measuring to performance levels of 5 places, and we have embedded into the software a method by which you can prepare standards in a standardized workflow using non-volumetric glassware. What this means to the analyst is that the standards and materials they use are free from impurities that may come from the cleaning processes of glassware, and because we are using smaller containers, you can reduce the environmental impact of the solvents you're using. So if I can look at the screen, we have a number of screens here which we have the opportunities to select user. This is a CFR 21 compliant system, in other words, electronic signatures. The user may log on, as I've logged on at the moment as Cliff, and from that we can begin selecting from a library of compounds. The library of compounds is selectable by the administrator, and that allows us to input information such as, if we press this, the molecular weight of the compound, which would actually be in the library, the purity of the compound, a lot reference, everything that gives us our traceability. So in this workflow, as you can see from the screen here, the first part we have is concentration and then units. So I can select by units I wish to make us. In this instance, I'm going to give an example of weighing out a solution in milligrams per mil. So I've selected this, and I'm going to use an example of weighing a standard to a concentration of 1 milligram per mil. So I can enter this as 1 milligram per mil. And you notice we have a batch reference here and a purity. This allows us to make corrections for purity and have traceability with that batch for future recognition. So we've selected this, and I press OK. So the user now is actually asked to place a vessel onto the pan to allow us to prepare that standard. So I'm just going to select a small disposable container. Here's a glass vial. By placing the vial on, you'll see on the display, it also now says, confirm that we've placed this on with tear. The tearing action of doing this allows us to zeroize, but it also will take us on to the next stage. The next stage is to ask the user how much they wish to prepare of this 1 milligram per mil solution, because we have a total amount here. So I'll select in this instance a volume. It could be any amount, but I'm just going to use 15 mils. And here I can have the opportunity to put the lot reference of the buffer or the solvent that we're using. So we can enter this figure, which will give us traceability to the reagent that's used. If I move over to here, the other piece of equipment which I need to introduce, this is a PAR densitometer, which actually has direct readout, if we can see on screen, to read the density of the solvent as well as the temperature. This information is used in the calculation of the volume afterwards, and we've had the temperature actually shown here as 20.7, which is entered, and then we're asked to confirm that's fine. So once we've actually done that, as you can see on the screen, what we have here is a target weight and a range which I've pre-selected to allow us to weigh within that. So I'm going to weigh into this my target value of 15.8 milligrams. Of course, you can never weigh exactly 15.8 milligrams. The idea of this is the instrument will make corrections to the volume that it's going to apply to the standard to make that concentration I originally requested of 1 milligram per mil. So here we'll enter the, or weigh out the amount of compound. Okay, I've weighed an amount here which is showing as 12.4 milligrams, which is fairly close to what we need to be. It's fairly quickly done that, and all I'm going to do now is it's green, so it says I confirm, and I can confirm that by using the OK button. Once we've actually done that, you'll see now it's actually saying I can press a probe button to zeroize the display here. This is the dispenser system here, which is incorporated a 25 ml syringe in this instance. The instrument, as initialized, is actually zeroing, and the next thing it's going to do, as you'll see on the display, it says the dispenser is filling. So it tells the operator exactly the stage that they are with the operation. As you can see, it's filled the volume now. I can now apply that sample to my standard. The thing we have here is we're not making the assumption that we've dispensed correctly. The instrument is now used, the density which it has for that solvent, it's corrected and shown me on the screen here a string of information that relates to the result in terms of its target concentration right through to the actual concentration that was realized. So if I actually print this off now, I can accept two levels of printing, a standard print and a print which actually is GLP compliant. In other words, it will give me all information related to the instruments that we have here in line with the period of when they were calibrated and certified. So I'm going to go to the print function and I'll select GLP print. The data printer here actually is on an adhesive print. If I wish to, I can select a two-stage print which also does a label that can be applied to my sample prepared. But if I actually show you what we have here, as you can see, it's given the company, it's given a date and time, and the user. It's also given the instrument, the balance, its serial number, the calibration date it was done, and equally for the dispenser, its serial number, right through to the densitometer, all the data related to the traceability of the instruments that are used. What we didn't see at the beginning of this was the fact that we're using traceable reference weights to validate the balance of the system anyway. By using weights such as this, which have a certified value, traceable to a national standard, they're put on to show a pass or fail figure onto the balance system to see that it's compliant. In other words, we have traceability. If I go back to the display, the printout here, as you can see that the printout actually gives me my compound, which was a salt solution, its molecular weight, the purity, and also given information about the solvent, its density, and the batch that it was actually prepared. It gave us our dilution reference, the concentration that we originally requested, and you can see at the bottom here, the actual concentration we realized. This is unusual in that we have a standard that actually is given what our target request was. We now have a 1 milligram per mil solution, which can be used as part of the validation of our method to standardize our instrument as an internal standard and as a means of measurement. Now, if that was a material which was too concentrated and we need to do a dilution, we are able to use the unit with a headset configuration, which allows us to select dilution. And then in this instance, I've preset this up by actually saying, okay, I want a 1 in 50 dilution on here. By pressing here, we've selected that as a ratio of dilution. It's zeroing here. There we are. So here we can select any dilution ratio we wish to have. We've selected 1 in 50, and I've selected a sample size of 20 microliters. I've done that because you can see that it actually shows you a final diluent volume here of 1 mil. This allows me to do a 1 in 50 dilution into a 1 mil container. So I'm reducing the amounts of solvents and materials down significantly. And how easy is that? Well, let's see. So on the instrument here, if we do a close-up on this, maybe you can see it, possibly here. You'll see there's a little air gap just at the end here. This is done as a separation. This is a totally inert fluid line. So we have our material, which is my 1 milligram. I now can do a pickup where it's actually here. You can see I've typed my diluent up. The next stage is to take my sample. And if you again look along the line here, we can see if we can pick that up, maybe. Let's try it up. You'll see there's a small air gap here. That's still the separation. And now by depressing the button here, now I've done a 1 in 50 dilution in a 1 mil vial, 2 mil vial, I beg your pardon, to a level and performance that you wouldn't realize using standard techniques. What this does is, in laboratories trying to realize their analytical targets for performance, by the ability to produce standards and make dilutions to a level of accuracy that you wouldn't achieve by using, as we stated before, standard laboratory glassware, allows laboratory not only to reach their analytical targets, but realize the comparative information that different laboratories have in their analytical techniques when they're using equipment which is cost them maybe several £100,000 of mass spectrometry equipment. This is a low investment to actually ensure they're realizing those targets. And of course, it stopped the high cost of the glassware, the cleaning of that glassware, general maintenance, and the analytical integrity they're realizing. So this product, as I say, is just being launched. It's a technique that's long overdue. Laboratories have been using, as I said, techniques that are now several hundred years old, to a technique that's now into a technology that our instrumentation market deserves.